So no calculator, power chart. You'll have a little half sheet that'll have 6 problems like these on it. And when you are done with those 6 problems, you will bring your paper up to me. I will hand you the second part of the test, and then you can grab your calculator, take it back to your desk, and finish up. So let's see. It says evaluate each logarithm. Do not use a calculator. Show your work. Ideas how we could do that. Snail shell it, yeah. Put an equals x or equals some variable over here and snail shell this. 3 to the x equals 27. And you will have a power chart, but do you know that one offhand? 3. And that's all we want, just 3. Because once you've done a lot of logarithms, you kind of snail shell it in your head and you say 3 to the something is 27. Oh, that's 3. So it really says 3. This little bugger looks a little more complicated, doesn't it? So let's try this one. Now, I know that I only use a negative power if it flipped. If it was a fraction and then it wasn't, or it wasn't a fraction and then it is. But this stayed a fraction, so I don't need any flipping. I don't need a negative. I just need to figure out what power could you raise 1 2 to get 1 and raise 3 2 to get 81. Well, thinking about the 1 would be silly. 1 to any power is 1. So we really just have to know 3 to the something is 81. And Austin, what you got back there? 4. Has to be 4. 3 to the 4th is 81. Again, you'll have your power charts. This one. What are you thinking? You doing the math in your head? 4 to the first is 4. 4 squared is 16. 16 times 4 is 64. Does it make sense that 64 times 4 would be 256? It's 4. But again, you will have a power chart for the test. 4 looks interesting. Snail shell it. Okay. What do I absolutely need with this one? 1's not a fraction. 1 is. How do you do that? A negative. Got to have a negative. All right, now, how do you get 64 to be a smaller number, to be an 8? Ooh, you take the square root. What's square root as a power? It's been too long. Okay, so then let's do this one this way. 64 has a base of 2. You're going to have your power chart, so you're going to look at it and you're going to see 2 to the 3rd is 8, 2 to the 4th is 16, 2 to the 5th is 32, and 2 to the 6th is 64. Now, 1/8 is 8 to the negative 1, but I want to write that as 2 to the something. So 2 to the something is, what's the something to give me 8? Then what did we do? This was called equating the bases. Yeah, we could just multiply these together and be done with the 2's. So that will give us 6x equals negative 3. Divide by 6. And we get negative 1/2. So that's the equating the bases way that we would do this. Like I said, some of you might look at it and just say, oh, it wasn't a fraction and now it is. That means it's a negative. To get 64 to be an 8, that's square root. Hey, square root is 1/2 power. So you might have been able to do that with just a couple of steps. Just snail shell it already? It's a fraction, and then it's not. So what happened? Had to be a negative. And then the 2 had to become a 32. Oh, I think we just did that. Oh, we did 64, didn't we? No, we did 32 in another one. 2 to the what is 32? Fifth. But you could do this. You could do 2 to the negative x. We need that negative because it was a fraction. Equals 2 to the 5th. Drop the 2's and equate the bases again. You get the exact same answer. Exact same answer. All right. 6 is one we're supposed to just look at and know. 7. Why is it 7? Faith's got it. The bases match. This is x, and this is x. Boom. Answer 7. That's it. So as long as the bases match, they're inverses of each other, and they drop right out. So this part of the test probably shouldn't take you real long. Like I said, you're going to have your power chart. However, we do have the whole class period, so, you can take that. One of the things I was hoping we could do tomorrow is, if everybody finishes the test, then I'll give you the 7-1 to 7-2 test back, because I think we're going to have enough time for everything tomorrow. Well, this looks like fun. Write it as a logarithm. That just means unsnail shell. That's all we have to do. So, working backwards, what was the base on this when they started snail shelling? 11. They raised it to what power? And the number they're evaluating is this big whopper right here. Now, again, make sure that your 11 looks like a subscript. It needs to be a smaller number. It needs to be a little below the rest of them. But if I snail shell this, I can check it. 11 to the 3rd is 1,331. Beautiful. Got it. For 8, base. Power for the right-hand side. And then that big whopping hole is where we need the 0.008, right? Right there. Again, make sure your 5 looks like a little subscript, not as big as the other numbers. Oh my goodness! Look at 9. It's got all kinds of stuff on it. That's not a normal cracker. That's a cracker with Cheese Whiz on it. That's what that is. Base. X. Maybe even Cheese Whiz and a green olive piece. Oh, good appetizer, little piece of that. Have you ever seen those goofy little, it looks like rye bread and it's like a little square, teeny little loaf? You take one of those, you put a little Cheese Whiz and a little green olive piece on there. Salty. All right. What are we raising it to for a power? A Z. That's why I put lines in mine and put lines in theirs. And the big gaping hole is filled with, and I probably better put some parentheses on that so it's easy for people to see. X to the Z equals Y over W. Yeah, Cheese Whiz and a green olive. Definitely. Well, there can't be much left. Graph each function showing the parent function, because that's what we do. And then the translation. Graph the asymptotes. Use at least 3 points for your table. I think those are really specific instructions here. So, number 10. Remember what we did yesterday? Snail shelled it? Yeah, you can snail shell lefty if you want to. I think most people can do that at this point, but you could also write it backwards. So what was the big deal about that? We're putting in Y's, yeah, not X's. You got some good numbers you'd like to try? -1, 0, 1, 2. Again, use numbers that would work from negative 10 to 10. So what's 3 to the negative 1 again? 1/3. You just flip it. 3 to the 0, 1. 3 to the first, and 3 squared. If I had to put a 3 down there, would 3 to the third fit on what we're doing? It wouldn't be horrible to put that down so you had something to aim at, but we don't really need it. Alrighty, so 1/3, negative 1. Oh my goodness, this is a little blurry up here. That is teeny tiny. What do you want me to do with that? Dot it? Can I solid it? How come? There's no H and K in this one. So kind of thinking ahead, we don't have any translations. And I have to make sure it does not look like it's going to touch the y-axis. So, I always want to graph asymptotes. I better graph that one. Right there. And I better tell them what it is, because there's a little space over there for that one. What's the name, the equation that will give people that line? X equals 0. Yeah, karate chops the x-axis. Good. So what does that make our domain? Greater than 0. Range. Did we have to do any describing about the translation? No, this one doesn't have a translation. That's it. That's what we get. No H and K piece. So let's make sure we did everything they asked us to do. Graph each function, showing the parent function and then the translation. Well, it didn't have one. Graph the asymptotes. Did that. Use at least 3 points for your table. We did 4. We're good. Same instructions. Let's look at this one. How do you want to start? Parent function. What would it be? Log of x. Yeah, we don't take the plus 2. That's part of our translations. So log of x equals, wait a second, we're missing a base. Yes, base 10. When it's not there, base 10. Then what? Snail shell. Numbers for that one. What are you thinking? Start with negative 1 again. Okay. Negative 1, 0, 1, that's 3. Should we put a 2 up there? Are we going to want to graph 10 squared? No. Wouldn't hurt, but kind of a waste. So 10 to the negative 1 is what again? A tenth. 1/10. 10 to the 0? 10 to the first? Dashed or dotted? Or solid? Okay, and that's because this one's not done. This one does have a translation this time. So 1/10 negative 1 about there, 1 0, 10 1. Ooh, that little bugger's almost flat. Where's this one going to go? 2 to the left. Will that change the location of my asymptote? Absolutely. 2 left is going to go right there, and there's a blank I have to fill in with the name of that there asymptote. What is it? You're close. X equals negative 2. And then, of course, you'd move your graph, right? Of course, Dieterholm. Of course, that's what we would do. Yeah, that's kind of pretty. Oh, my arrow doesn't really show up, though. I got to make sure I have arrows on both ends. It has to be going forever. So what's our domain? X is greater than -2. What's our range? Did we do everything it asked us to do? And a little bit more, right? I mean, we've got the description of 2 to the left up there. Is that it? 11 problems. Beautiful. That's it. So, what was that for? Maybe I put that there in case I thought you might need one more. Do you need one more for graphing? Okay. There we go. So I will get you candy partners, and you will have the rest of the time to work on this little review assignment here.